There we go. We are now live. All right. We left off. Damn it. That's where that goes. On this side. Because we went through these and talked about them. We didn't do this because it was a theory question. And then we looked at that, but that comes after this side. So it starts right here at these ABCDs because we did cover these.
Yep.
All right.
I wish you would just tell us what kind of problems are going to be on there.
So yeah, that's the thing. So in his breakdown, he just tells us the chapter. He doesn't give us. He just tells us that like as long as you have these chapters like solid and this chapter like 50%, you're basically fine. And then this time though, it looks like we just get a whole piece of paper, which is great. All right, let's hit it.
What to put on it though?
Oh, we'll do that. We'll do that at the end because I think with all these tests, let's see at the bottom. This one, I guess I didn't have a formula sheet. It's probably test 3, I guess. Yeah, I don't know why I didn't have a formula sheet.
I didn't have one for that one either.
And let's see. I did have a formula card for this one, and then I know I had a formula card for the second one. So we have a lot of the formulas. If I didn't have a formula for this, I probably didn't need a formula sheet for this.
But do you need one now?
I don't know. Maybe. Probably. Look at this shit.
I know for test 3, I forgot to like scan the note card because I didn't use it, so it should be fine.
Yeah, it's just we might want to put these down there, but then there's this formula. So luckily, we have a lot of the formulas already written, and we just have to take these and put them onto a big sheet. All right, let's start with going through. We'll start at A and look at these questions. So if u is a unit vector, the derivative of f at some given point in the direction of u is f of x at point I plus f of y at point y j dot in the direction of u is, oh, okay, I see what it's asking. So it's essentially asking, is, the derivative of f at a given point in the direction of u represented by the formula it gives, which is the gradient of f at the given points, ij, dotted with the given unit vector u. And isn't that exactly the definition of directional derivative?
Yeah.
So you would take, if we were to just give an arbitrary function f of xy and an arbitrary point of 1, 1, and then you take the gradient derivative, or just gradient of f, it would be y I plus xj. Evaluate that at 1, 1. You have I plus j as your gradient, and then you would dot it with u, and that is the definition of the directional derivative. So yes, A is true. Yeah. All right. B, the derivative of f at given point in the direction of u is a vector. No, it's a dot product, so it isn't, right? It's a magnitude or just a scalar.
Should be.
Yeah, it's just, since it's a dot product, it's just a scalar. So it is not a vector. C, the directional derivative of f at given point has its greatest value in the direction of the gradient. Isn't that also part of the definition? Yes. Yeah, that's true. And then at given point, vector gradient is the normal to the curve. Yes, the gradient's perpendicular to the curve because the curve is what you take the gradient of, and then that's why it's the absolute magnitude, right? Because the curve itself is those what are the level curves. So if you sketch the function, that's the level curves, and then the gradient is perpendicular at some given point of the level curve. And I can demonstrate that by going into the courses, assignments, and pulling up the test. This is test 2 topics, right? If I remember correctly.
I think so.
And I can demonstrate this because we had to do this in the
test 3.
first. We had to do this in the first question. It wasn't test 3 because I can tell you if we scroll back up here, it's not there. I have the others open. Test 2 is right here. Pull that up. 12 megabytes. Oh boy. Taking its time. But yeah, so that's also true. because you sketch level curves, which is just sketching the function evaluated. And then right here, you can see my terrible gradient sign looks like a capital D evaluated at a given point. It is equal to some vector or some, scalar point. Is it a
Mhm.
vector now or what? How does that? No, it's a point and then I drew something. I don't know. Maybe it is a vector.
It looks like a vector.
Yeah. Maybe it is.
What did you
Oh
just
wait,
say?
no, it's not. It's not. The directional derivative is not a vector. It is a scalar. This is the gradient. The gradient itself is a vector.
Okay, yeah.
You're misconstruing, but yes, the gradient is. So here's the function f, which in this case is just a circle when you evaluate it. And then here's the gradient of f, which as you can see, if you evaluate it at any given point on any of these function level curves, it will be perpendicular at any given point. Like here, it's literally along the y-axis, which is perfectly perpendicular to my horrible circle. So yeah, that's that. We did greatest value and we talked normal. So all of these are true, every single one of these. All right, now we get to talk about tangent planes, gradients, and normal lines. Find the equation for the plane to the specific level surface at a given point. Also find a parametric equations for the line that is normal to the surface at P0. So our first thing is we need to find an equation for the plane tangent to the level surface. So what's our process for these? So we'll do 47 obviously because that's what he circled. So we have x squared minus y minus 5z is equal to 0. Then P naught is 2, negative 1, 1. So it's talking about surfaces. So the first thing we can do is look through this and get down to 13.
Well, if we're looking for the perpendicular to the plane, that's going to be the normal vector, and the normal vector is found through
It says find an equation for the plane tangent to the level surface.
Isn't that the definition of a
So I think what it's giving us here is our level surface, and C is equal to 0 here.
yes.
And then we have to find a plane that's tangent to the level surface.
And
So, I think I remember this.
Don't we
It's
need to
kind
get
of like the saddle point kind of like stuff, or no?
I don't think it's there yet. This is like saddle point stuff. It just says find local max. So it wasn't in that. Maybe it's test 3 topic. I don't know.
Because
Nah, it
what you're
can't be.
looking at on that figure is an x squared. So your x dimension is going to kind of have like a parabola thing. And so your tangent plane is going to have to be where the midpoint, whatever I can't think of it right now, of the parabola is.
I mean, yeah. Yeah, because it says find a plane to the level surface at the point P. So it gives us a point. So the first thing we can do is sketch a figure using the point, I guess, in a 3-dimensional space and work from there. I looked, so this is test 2 topic, and I didn't see it immediately in my test 2. So maybe it doesn't show up, or maybe it will. Who knows?
always hope it won't show up.
Yeah, it's
So we should be ready for when it does.
Yeah, it's an application. So level surface, you would have x squared minus y minus 5z equals 0. Does the point even satisfy it? I don't actually. I think it does. Because what you have 4 plus 1 minus 1.
Yeah, minus
Or
5.
minus 5. Yeah. It's equal to 0. So the point satisfies that function. So that's cool. So we go 2, 1, or negative 1, and then 1.
Okay, so what if we take the what's it called? What's the little diamond? What's the little
The
like
gradient.
gradient? The gradient should give us a line tangent to the plane at a point, right? Is that not what a
Actually, I think
gradient
the
is?
gradient gives you the plane
The gradient would give us.
because it's it's 3 dimensions.
What's the
So I think you
definition?
literally just take the gradient at the point.
And then, but we also, we have to do parametric equations for the line that is normal to the surface at P0. So the gradient is going to be not tangent, but normal. So I think the gradient is normal to the system at the given point. Normal to the surface. And then in order to find something
I
that's
think for the
tangent.
parametric equations, you can just take the plane and like, I don't know, maybe find. I think you just do a cross product with something. I don't know.
Maybe. I don't think we've ever seen a question like this. That's why I'm confused. I'm going to see if I can find the worked solution to this and see what the process is and if we recognize it. Let's see. We have a mathematics stack exchange entry. Beautiful.
Page 717 in the book gives an equation for a tangent line to a level curve. That looks like you might be able to make it 3 dimensions. But I don't understand what the hell it's saying.
Yeah. Tangent planes and linearizations. It just says tangent planes, and then it just talks linearizations and estimate change, and then something else. Another
And what
estimate
is
change.
this? What is this question? Like, what number is it?
47.
47. The answer is 4x minus y minus 5z equals 4.
Oh, I got it. I think maybe. Tangent plane to surface.
You said it's 4x minus y minus what?
Minus 5z equals 4.
Y is the only thing that changed there is the x.
Okay, I found definition.
Yeah, I think I
So
found equations.
The tangent plane at a point on the level surface of a differentiable function is the plane through the point normal to the gradient. And the normal line of the surface at the point is the line through the point that is parallel to the gradient.
Yeah, so the process for doing a question like this, I just found a more complex version, but it's a process that goes across. So the first thing we do is we take the gradient of it, which obviously becomes a vector, and we evaluate at the point. So let's start by taking the gradient of this and evaluating it at a point. So the gradient here spits out a 3-dimensional vector, I believe. So the gradient of our f, x, y, and z is equal to 2x I plus, well, now it's just x squared minus 5z j plus, looks like just x squared minus y k. Across the board, evaluate at 2, -1, 1. So the first thing you get is 4i plus 4 minus 4 minus 5j plus 4 plus 1k, which is 4i plus negative or minus 1j plus 5k. Now the next step here is the equation of a plane tangent is given by, a x minus x0 plus b y, that whole thing, equal to 0. So what we can immediately do is take the coefficients on our ijk from the gradient, and those correspond to a, b, c in the plane equation. So we can construct a plane equation that looks like 4 times x minus the x entry for the point, so x minus 2, plus or minus 1 times y minus, which is plus here because it's a -1, which is plus 1 plus
Wait,
5
so what did you get for your
vector
partial, or no,
gradient.
gradient?
4i minus j plus 5k, because the partial for x is 2x.
Okay.
Oh, I messed up. The partial for y is just
Should
going to be
be
1.
-1.
Partial for z, yeah, -1. And then the partial for z is just going to be -1 again, right?
-5.
Yeah, you're right, -5. Yeah, so -5, -1. So it's 4, -1, -5. Because of 2x, -1. Yeah, so did you get 4, -1, -5?
When evaluated at the point, yes.
Yeah, so that's what you got to do. Yeah, so there's that. So I was just wrong on my last sign because I messed up. But even so, then you do -5 times z minus the point entry for z, which is -1 here, and it's all equal to 0. So evaluate out. So multiply across. You have 4x minus 8 minus y minus 1 minus 5z.
Wait, so what do? You cross it with what?
You don't cross it. You just construct a formula here. So
Oh,
you
this
take,
is our normal.
this is our tangent plane. This is our tangent plane.
Y minus 4z equals 4.
It looks like it's gonna end up like that. So
Okay.
this looks like it's
You're
correct.
confusing me. What?
Yeah, I'll finish it off in a second just to confirm that it is right. So we have 4x minus
I
y
see.
minus 5z is equal to -5 plus 9. Yep, +4 on the right-hand side. This is the correct way to find the tangent plane. I have to turn down the brightness on my second monitor. I look like a ghost. There we go. All right. Yeah, so this is the proper way to find the tangent plane.
Okay.
So the proper method to find tangent plane, given a function and given a point, is to take the gradient of the function, evaluate it at the given point, which will spit out a vector. Each of the coefficients on your I, J, and K correspond to the coefficients A, B, and C for constructing a plane with the standard plane equation. So those coefficients come in, and then each of those coefficients is times x minus the corresponding entry from the given point. So in this instance, you would take 4 times x minus 2, and then the next entry is -1 times y plus 1 because it's a negative. So y minus -1 is y plus 1. And then the next entry is -5 times z minus 1 is equal to 0. So you construct the plane equation, set it equal to 0, and then using the constants from the point, you sum those over and pull them to the other side.
And what did you get for your d value?
The d value, or in this case, it's not d, it's just 0. But either way, it's just 4. So that corresponds with the book answer. So knowing that, so that's how we do that part. So now we have to do the parametric equations for the line that is normal to the surface at P0. So now we have to think about this.
So which one are we doing? Sorry. So 49 or 51?
47.
It's the line parallel to the gradient through P. So I think it's more of a plug and chug.
Yeah, so what it is, so the line that is normal to the surface at P0 is simply the gradient of the surface, which will spit out a vector. It's the line. And then we simply have to parameterize the vector, which we know how to do. We've done that before. We know how to construct a vector from parametric equations of x, y, z, and we know how to do the inverse. So same vector here. It's going to be 4i minus j minus 5k. So there's our vector, because that's the gradient, because it's the same thing. That's our line. And then parametrizing this, doesn't this end up being, is it 4 minus t for x?
X
Or
will be
t
4
plus
t
2.
plus 2.
Where'd you get the 2 from? Oh, the point. Whack.
Yeah,
you're
so
right.
your constants
Forgot
are
about that.
literally just the points.
Yeah.
So you set
Yeah.
t equals 0.
4t
And then your
plus
t's
2.
correspond to
So
the gradient vector.
y is going to be equal to -1 minus t. And then z is equal to 1 minus 5t. And those
That's what
are
I got.
and that's the method for parametrizing. So that's something that I know that like we've done it enough at this point to kind of understand it pretty well. Like the coefficients on an I, j, and k correspond to the t when you're doing x, y, and z. And then the constant of a given point corresponds to the constant in the x, y, z equation as well. But it's probably, when we make the formula sheet, we can probably just write out a general form for that, just so people don't forget. Because that shows up everywhere, honestly. All right, let's look at this and see if it's any different. Find an equation for the plane tangent. So we just did this. We're just not doing the parametrizing. Do you guys just want to do 49? It doesn't look too bad, just because for extra practice. All right, now that we know how to do this proper, now this one only has 2 variables, so it simplifies it. So we start with the gradient of this. So gradient with respect to x is going to be what? It's going to be 1 over is an x squared plus y squared, but then you take the derivative and then multiply it across the top, which will give us 2x, right, for ln on I. Any issues with that derivative that I just spit out? I might be wrong.
Wait, for the derivative of
Well,
what?
the partial derivative with respect to x of the function z, or
And
f
you
of
got
x.
2x over x squared plus y squared?
Yes.
No, okay.
Okay.
Yeah.
Legend. All right. And then it is going to be plus. Why did it give us 3 dimensions here?
Because it's z is the equation. It's z is equal to.
Yeah, you're right. So that just changes up the. Huh.
Now, my
It-
gut is telling me to just subtract z from both sides and then treat it as
See,
the
it
previous.
says that, but like if you look at the previous one, it's f of x, y, z is equal to c when talking about like the question itself. But in this one, it says z is equal to f of x, y. So I don't think we do that here. I think we just leave it. And then the difference would be in modifying your plane equation. Because for us, our plane equation started by being set equal to 0 instead of d, since we're given a point. But I think this time, like let's look at 50, for example, even though that's not something that's required for us to do. In 50, instead of it being a 0 as our third dimension, we have an actual number. We have 1/2. So I
Okay.
suspect that instead of it being 0 when constructing the plane equation, we start with just 1/2 on that side as part of the constants. Or not, who knows? But the reason I
Okay.
think that is because it says f of x, y. So it's intrinsically telling you that it's not like z is not part of the function. Z is just defined as f of x, y.
There's a specific formula for this.
Which is there actually a proper
Hit
like
me with
super
it, Ryan.
formula?
Hit me with it. Let's go.
Literally for this. So for the function z equals f of x, y at the point x naught, y naught, z naught, or x naught, y naught, and then for the z point, it's going to be f of x, y. Like for the point.
Okay. Yep. Yeah.
It's going
We're
to
good.
have, the partial with respect to x at x naught and y naught times x minus x naught. And it's essentially the same thing as in the previous one, like the first 2 parts. And then for the z, it's just going to be z minus z naught.
Like in the plane equation? When constructing the plane equation, we just treat z as we would treat it?
So there's no coefficient for z?
Yeah.
Okay.
Well, coefficient is 1 or whatever you want to call it.
I'll take it. So it's still set equal to 0. That's good to know.
Coefficient, the coefficient's actually -1 on that formula. because it's partial x at the point x minus x naught plus partial y, y minus y naught, and it's minus z minus z naught.
Yeah, because that's what we would do if we were rearranging the equation, I suspect. All right, and then we have
Yeah.
our j. So I have 2x over x squared plus y squared I plus 2y over x squared plus y squared j. So then we can evaluate it right here, which is evaluating at 0 and 1. So evaluate the first part at 0 and
This
the
is
I
a 0.
drops out. Evaluate the next part and you just have 2
Over 1.
Yeah,
Which
so
is
just
2.
2. Yeah.
Yeah.
So we just have 2j here. This is an easy looking one. So that means we only have a coefficient for our plane equation of numbers for our y and z if given formula is correct here. So then that means we will have 2 times y minus 1 minus z, which is minus 0, because that's its entry here with the new formula we just discovered, is equal to 0. So then we have 2y minus 2 minus z is equal to 0. Rearrange this to 2y minus z is equal to 2. Let's see.
In the back of
what
the
I got.
book, the back of the book says that, but the back of the book also left it as 2y minus z minus 2 instead of moving the 2 over.
Same thing though. That's good to
But
know.
that doesn't matter. That's
All right.
algebra.
So the function that Ryan just mentioned, the construction when given in the form z is equal to f of x, y, the plane construction formula is set as a times x minus x naught plus b times y minus y naught minus c times z minus z naught,
Wait, right back.
although in these instances, c probably won't exist. It'll just be 1. So c can mostly be set up as just 1 because of the nature of it. All right, so that's how that formula will work from here on out. So I'll keep a note of it for later. Let's look at this. Find equations for the lines that are tangent and normal. So this is what we're doing up here, because finding something that's normal, find equations for lines that are tangent and normal. So this is finding equations for lines that are tangent and normal to the level curve at point, whatever. Then sketch the lines and level curve together with the gradient. Okay.
Wait, which one are you on?
51 now.
Okay.
I'm pretty sure he did this. Did he do 51? Yeah, he did 51, which is good. So let's we won't have to go scrambling for answers here once we're finished with it. So the function here is y minus sine x is equal to 1, but I'm inclined to just write this as, actually no, it is f of x y. I'll just leave it as is. Sine x is equal to 1 with our given point at pi and 1.
Oh, okay.
So we have to find lines here. We're not finding planes. Lines that are tangent and normal to the curve at the point. So the first thing we can do is find our normal line, which is easy. It's just the gradient. So that's not that bad. So just the gradient of this isn't a problem. So we can do that real quickly. We'll get to the tangent when we get there. So the first thing is going to be negative cosine x times I, and then we have plus, looks like, well, not plus, just going to be minus sine x here then. Or no, it's going to be, yeah, minus 1. No, it's going to be plus 1 minus sine x. No, it's not. No, it's not. I am derping on the derivatives. It's just going to be 1. So it's just plus j. So evaluate this at the point. So negative cosine of pi. Cosine of pi, as we mentioned yesterday, is negative 1. So negative of a negative is a positive. So we literally just have I plus j here for our gradient. Cool. Let's see if that's correct. In his notes, he also ends up with I plus j, so that's cool. Now, how far does he take it though? because we also have to doodle stuff here. So if we were to draw this function, so I guess the first thing we can do is draw the level curve here. So this is just going to be on basic Cartesian coordinates. And you can rearrange the function when you're just drawing it. So this can just be y is equal to sine of x plus 1. We all know what sine of x looks like when it's just y equals sine of x. But since it's plus 1, that means we shift it in such a way that sine of x never goes negative. It just ends up either at 0 or 1, or 0 or 2, I should say. So it's the same sine function you're used to, except its lowest and highest points have shifted 1. So now instead of starting at 0, it starts at 1, and it bottoms out at 0 and tops out at 2. So since we're required to sketch the level curves, that's probably what we're going to need to do. And then at the given point, which is pi, as we're aware, so that would just be, half cycle pi. We have our gradient, which we also have to sketch, which is the perpendicular line. So you can just draw a perpendicular line and denote that it's the gradient at the point. So there's that. We've done the perpendicular line, the normal perpendicular line at the point. So now we have to find a tangent line. Huh. Okay, well, that's interesting. All right, so new formula, gang stars, for tangent lines. Tangent line formula is the partial with respect to x of the function times x minus x naught plus the partial with respect to y of the function times y minus y naught is equal to 0. So this is suspiciously like a plane equation.
Super easy.
Yeah, but it's slightly different. So still not that bad. Partial with respect to x and y evaluated. Are they evaluated? They are evaluated, and they, as we know previously, the partials both evaluate to 1. So it ends up being x minus pi plus y minus 1 is equal to 0. Rearranging that to set it equal to y is just going to be y minus x plus pi, or y is equal to negative x plus pi plus 1.
I think that's supposed to be a positive x.
I'm back. Where are we at?
So the formula here is partial with respect to x times x minus x naught plus partial with respect to y times y minus y naught is equal to 0. So we evaluated the partials previously to find the gradient vector. So we know that those both evaluate to 1 at the
Okay.
point. So that just drops out.
No, when you take the partial of
No.
negative sine x, it's going to be -1 when you put pi in there.
Where do we get?
Like, you're taking the partial with respect to x, and you're going to get negative cosine x.
Yes.
And that's going to be -1.
It's -1, but it's a negative cosine x times a -1, so it's +1, right? Because cosine at pi is -1. Because cosine at pi over.
You're right.
Yeah, that's why, because I remember from I of j. So that's why it's 1, 1 in this situation. So now that we have that, we know f of x and f of y are both 1. We're left with x minus x naught plus y minus y naught is equal to 0. Plug in, you have x minus pi plus y minus 1 is equal to 0. Theoretically, you could leave it like this, but I don't think that's what he wants. He wants it in forms of like y is equal to. So rearranging the formula, we'll have y is equal to negative x plus pi plus 1. You could probably find a way to combine pi and 1 into one constant. I refuse, and in his notes, he didn't do it either. So I don't think we'll have to.
Acceptable answer.
Yeah, so that's our line. And when it comes to sketching it.
So you mean the tangent is x plus 1, y equals pi plus 1.
The tangent is y is equal to negative x plus pi plus 1. That's just from rearranging it. And obviously, since it's tangent, you can't really draw it effectively, and he couldn't draw it either because it's just probably just on the line. Well, you could probably figure out a way to draw it, but he didn't draw it, so who cares?
With the internet.
No one needs to draw it, I suppose. So that is how to do, that was this one. So that obviously that same process will apply to all of these. So the only new thing that we learned with respect to this problem is how to find a tangent line as opposed to a tangent plane.
How much stuff do you think we'll have to draw on the test?
If we go back and think about our previous exams, we did this once. No more doodling in this exam. No more doodling in this exam.
It's probably, we're gonna have to doodle once.
And then in test 3, we doodled this once, but I don't think this is even required. I just do this because that also, none of this is required, I don't think. Really, it's only level curves that he'll tell you to draw. I don't remember if he made us draw these. These are just helpful. And
That's
then,
not even on the test.
and then these things. I just, figures help, I suppose, but it's not required. Is this the most recent one? I don't even remember what happened on this exam. Oh yeah, this is the unsolvable integral, right?
Yeah.
Yeah.
Dude, I freaked out when I got that. I was
Dude,
like,
look, I did it. I got to here. I crossed it out. I'm like, screw it. I did the rest of the test and I came back to it and just BS'd it beyond all measure. That's how it works sometimes. And here's something funny. I had him for Cal B and he made a mistake on one of his tests that also made it unsolvable. He made it
Did he?
so like, yeah, there was, it wasn't an integral though. It was for something else with relation to the radius of a circle function wasn't actually the radius. Like it didn't work. It was impossible to solve the function. Like the R was the wrong number.
Yeah.
So I like called him over in the middle of the exam and said like, shouldn't this be like 5? It's the only way these numbers work. He's like, oh yeah, you're right. And then he made us change it. You were there,
Yeah, he
John.
did.
You were
Yeah, he
there.
did.
All right, let's see.
I
Let's
think
move
you
on.
get extra credit for that.
I did not get extra credit. No.
Goal.
I mean, I weighed my options. I sat there and I knew it was wrong, and I sat there for like 5 minutes. I'm like, is it worth, like, because no one wants to be the guy who calls out like the professor, just calls out anyone, honestly, particularly in a testing situation.
Yeah, I don't like to disrupt test, but if I like, I'm fairly certain that is broken.
Yeah, if
then,
I
oh,
see
man.
this, I don't want to see this. All right, let's move on to 55, which is linearizations, which has its formula right here.
Oh, it's in there somewhere.
It's right here,
Oh,
this thing.
yeah.
He actually gives us
Oh.
this one, which is nice. Everyone write down the linearization formula because we're probably just going to use it immediately. So this is actually, we don't even need to write it down. It looks like it's just the function evaluated plus the partial evaluated times x minus x naught plus the partial evaluated y times partial.
Similar to like what
partial.
we've been doing.
Yeah, yeah. So we just add on an extra constant in the form of the function evaluated at its point. So which one of these, what is the, find the linearizations of the function at the point. Okay, so he crossed out this part. So this is useless. We're not doing this in these questions, which is
Yeah.
nice because that looks dirty. All right. We'll just start with 55. These probably are, this is plug and chug, so it's not a problem. F of x, y is equal to sine x cosine x.
The last
Cosine
part is talking about like linearization error and like stuff like that, I think.
Yeah, I don't care. I don't want to.
Oh.
He crossed it out for a reason. I'll just be like, nah. Yeah, it's like find the magnitude of error in the approximation. There's a formula for it, and I know we know it. We did it in the homework, but we didn't do it on the test, so I don't care. So the formula here was L of xy is equal to the first thing is just the regular formula, just regular f of x evaluated at the given point. So it's equal to sine of pi over 4 times cosine of pi over 4 to start. Then it's plus the partial of the function with respect to x evaluated at the point. So the partial with respect to x is just going to end up being it's just be cosine x cosine y.
Yep.
Oh, why did I write 2 x's?
Yeah, and then evaluating cosine x cosine y at the same thing is technically going to be cosine squared of pi over 4, but we'll talk about that later. And then the next step is going to be evaluating partial with respect to y of the function, which will spit out negative sine x times sine y, which again, if you evaluate it at pi over 4 for both, it's just negative sine x squared. So there's two things we could do here, right? We have a cosine squared and a sine squared by technicality. Yes, because x and y are equal here. So we could just say mathematically. So do you guys just want to reduce the set to 1? The cosine squared plus sine squared, or is it cosine squared minus sine squared that you have to have, which we do have?
Wait, where are you getting cosine squared from?
So what we actually have in this function is, sine of pi over 4 times cosine of pi over 4, which is evaluating it normally. The next step is the partial with respect to x, which spits out cosine x times cosine y. Normally, that's not cosine squared. But in this instance, the point has x and y being equal to each other. Therefore, mathematically, I can say they are the same. I can say x equals y equals pi over 4. Therefore, I could say this is cosine squared. And then same thing with sine. Negative sine x times sine y, when x and y are equal, is functionally the same as saying sine squared, or negative sine squared. And that seems a lot like an identity we know. Cosine squared minus sine squared.
Or hear me out. We can
Cosine
just
squared
evaluate
plus
it
sine
as 1
squared
half.
equals
I don't
1,
want
but
to. What'd you say?
Evaluate at 1/2.
Evaluate at pi over 4, but yeah.
Yeah. In this case, I think it would be easier to just write 1/2.
But I want to be big brain here. I want to do something cool. Okay, fine. We'll just do it the normal way. Negative sine x sine y. Evaluate everything at pi over 4 here. So pi over 4 is what?
45, which is root
Yeah, it
2
is
over
45
2
degrees.
times
So
root 2 over 2. So root
no, it's 1/2.
4 over 4, which is 2 over 4, which is 1/2.
Yeah, and that's across the board for every single one of these. Except one of them has a negative sign on it.
And then the pi over 4s cancel out with each other.
Yeah, 1 over 2 plus 1 over 2 minus 1 over 2. So it's just 1/2. Right?
Yep.
Yeah, it's 1/2. Let's see if he answered it in his notes. He did not, but this is formula-wise. Let's see if I've done a linearization in a homework before. Did I put the formula for that on here? I did put the formula here.
What is this? What is this question? 55? Okay.
Do we get booked?
We don't know because 55, the answer to 55 doesn't answer the first part, it only answers the second part.
Heck.
That's awesome. Well, I put linearization on the card, but it didn't show up in the test, so legendary.
But
we can
the linearization I think should be 1/2 plus x over 2 minus y over 2.
Why x over 2 minus y over 2?
Because we're trying to get L of x comma y. And so we get 1/2 plus x over 2, and we get that by saying the partial times x minus x naught.
Oh, yeah, forgot about that part.
Yeah.
Let's go to
And
that
then the
formula.
same with the y.
Formula's right here. So yeah, forgot about that part. So we just have 1/2 plus 1/2 times x minus pi over 4 minus 1/2 times y minus pi over 4. As you said earlier, the pi over 4s drop out because of a sign difference, and then we have 1/2 plus x over 2 minus y over 2, correct?
Yep, I believe so.
Yeah. I don't know, it's just a mistake of not using the formula properly on my behalf. Don't do that,
Because you
kiddos.
tried to cheat.
I didn't try and cheat. I was telling you guys that the cosine and the sine probably drop out, and it kind of looks like they did. Not gonna lie.
Yes,
I
they
don't know.
technically did go 2, 1.
I don't
Did
know.
they go
Actually,
to 1 or 1.5?
it looks like the sign was wrong. Looks like instead of going to 1, they went to 0 instead because the signs were opposite.
We can't say that because the identity is cosine squared plus sine
Yeah,
squared.
that's why I
And
said
then
the
this
signs
is
are
cosine
flipped here.
squared minus sine squared,
Yeah,
which is
so
nothing. I actually think it's a double angle formula.
I don't want to talk about double angles ever again. All right, so that's how you do that. It's basically the same process, except this one would be infinitely easier because it doesn't even have any trig. This is just plug and chug. So that's why we're not going to do it. You know, my email is pestering me. All right, what's this? Find linearizations.
Cosine squared x minus sine squared x is cosine 2x. So
It is beautiful. All right, this is another linearization, except it's got 3 dimensions, but that changes nothing. It just adds. Wait, no, does it change something? I mean, all I can imagine is that if it's got another dimension, you just slap on a partial z times
Yeah,
z minus z naught.
sounds right.
And this one's just asking you to do it at 2 different numbers. So I don't think it's worth going through this since it's just repeating the step again.
yeah, it's fine.
And this one's an easier one as well. It seems like he wants us to know how to do these more than this. Do we even care about this? Let's see if he talks about it at all. I don't think
let's not care about
I don't think
sensitivity.
we've ever mentioned it. If it doesn't show up in his topics thing at all, yeah, okay, yeah. He skips out on the sensitivity stuff and just goes right to saddle points. Estimate of change, I know, like, is something, but the thing is, it's just the gradient dotted with a given vector. So we really.
That's what that question was talking about, is estimating change.
Oh, well, screw it. We'll do it then. It's a formula. I don't care. Sensitivity change. Is it more sensitive to changes in the x or the y when near the point 1, 2? Okay.
So what we do is we do it both. We linearize in terms of y and x. I don't know how to do that, I'm gonna be honest with you.
No, doesn't it? So the formula for this says that it is the gradient dotted with some vector.
So if we use like.
So what we would. So yeah. So who said it was like? Yeah, Ryan's got it. So Ryan knows what's happening. So what happens here is we take the gradient. We all know how to do that. That's not a problem. Dot it with constructed vectors. So we have to construct a vector here. It's what it's asking us. Is it more sensitive to a vector in the x or the y direction? So as Ryan said, we would just make the vector u equal to I here, and then here equal to j. Dot it and find what number's bigger, I guess.
Yeah, bigger. Probably.
Yep.
50.
Let's see if he worked this in his example. He did work this, so that's good. So instead of working it by hand, I'll just see through. I'll drag it onto the screen. And we can look at 60 here. So what did he do?
Gotta read it first.
Yeah, so if f of xy is equal to that, more sensitive to change in the y or the x, how do you know? More sensitive to small changes in y, 1 is equal to 2, because
you just take the partial in terms of x and partial in terms of y, and then evaluate it at the point.
That's it? We don't even do the dot? That's whack.
That's what he did.
I mean, you're right, so I guess we don't even need to do that. Okay, cool.
Which, that's the definition of a partial in terms of x, is the change in the x direction.
Yep. That is the old tests. All right, well, that's what that is. Okay, let's get away from that. Yeah. Yeah.
Is this a saddle point one?
He didn't even talk about saddle points here. He just got rid of it. Well, not in 13, but wait.
Oh, this is stuff.
This is like this stuff.
You know, the fun stuff.
Yeah, the good stuff. So he literally didn't even talk about saddle points or didn't even mention it. I mean, he talks about it here, so it's best to just have literally this section just on your card. That's all you need to know. All right.
I mean, you get a whole page front and back, so
Yeah,
it's gonna be hard to even fill that. So you can throw a bunch of stuff on there.
Yeah. So let's start with these double integrals. Regular double integrals are like really just pluggy chuggy, like really not that difficult. It's really more a matter of understanding how to integrate sometimes. Sometimes it gives you a tricky function. So let's think about it. So which one of these do we want to do? We could do one of them since they're all functionally the same process, it looks like. Actually, it's a little bit different. Well, should we do, we'll do number 1 and then we'll do number 5 because number 5 is asking for something different. So this one's just sketch the region. So I guess we just sketch the region.
I don't want to sketch.
Yeah, no one wants to sketch, but he probably made a sketch. If I remember in this homework, there was a doodle somewhere. Yeah. Yeah, he did say sketch the region, so he actually did have to do it.
Trash.
So if I'm right, what we do is we sketch the region of the bounds, right?
Let's find out.
Yeah, so basically what you do is since your dy is the back one, you basically say, you know, y is going from 1 to 10. And then you draw the lines for the x.
Yeah, look, I said y is equal to 8 here, y is equal to 0. So there's your 2 lines, and that's from this part. And then we have 0 to 3 root y, and this is what that looked like. I don't know why I said it went down, but it doesn't really matter. Oh, it's because I'm oh, it's not 3 root y, it's the cube root of y. Genius. So that's why it's x cubed. All right, let's go back to this and do that then. So we can start with our Cartesian coordinates, x, y, and then we can immediately say we have 2 horizontal lines, one at x equals 10, or y equals 10, sorry, and then another line at y equals 1. So there's that. So that's the first boundary. And you got to pay attention. If this was dy dx, then the boundaries would be shifted, and you got to make sure you know that, because these things, like, look, this one literally does exactly what I just said. Then the next thing it's asking is from 0 to 1 over y, which is, why does y gets, how do I forget what 1 over y looks like?
It's reciprocal function thing. Wait, actually it's x equals 1 over y, so yeah,
I think
that's
it's still like
reciprocal,
this.
right?
Yeah, it's just 1 over x then. When you reevaluate it in terms of x, it's just 1 over x.
I think it's just 1 over x. I think it's literally the same thing.
Yeah, it just ends up 1 equals x. So obviously at 0, it doesn't exist. And then
I get infinitely closer.
Yeah, and then at yeah, so it looks like super, I know it, never mind, I know what this looks like. There's actually going to be an intersection. It's going to go under that. And then over here, it's going to be under the whole time. Right. Doesn't it look like that kind of thing? Where you have the lines along the axes inverted? It's a little bit sketched out.
Yeah.
So then the actual region of integration here, let me see what I did on this exam.
In the first quadrant.
Yeah. So in our first quadrant, the region of integration is just right underneath. It's in this dotted zone right here. It's really small, actually. It's really tiny.
Depending on how you draw it.
Yeah. It's not really that small. I think it'll be decently large, but I don't even think we get to. Do we get to evaluate it?
Yeah.
We do. All right, nice. Let's hit it. All right. First integral, we have to integrate y ey in terms of x.
So we take out y, right? We can just take it out.
Yeah, because it would be divided by y, and now we just stuck with e to the x. But now it's e to the x, and then we have, e to the 1 over y minus e to the 0, which is 1. So now we have e to the 1 over y minus 1. When moving into our next portion, which is with respect to y. So taking the derivative of e to the 1 over y with, taking the integral of e to the 1 over y with respect to y, isn't this just going to cause it to be y times e to the 1 over y, right? If you divide by 1 over y, it flips it.
It's
Oh no, but yeah, it's with respect
so
to y though.
I got for the simple antiderivative, I got e to the x to the y, e to the x times y, right? Because y is going to be a constant, so we can just pull that out to the front
Yeah,
because
e to
it's
the
in terms of
xy.
x. So then we get the antiderivative of e to the x times y is 1 over y e to the x times y. And we can cancel out the y and the 1 over y together. Make 1.
1 over
so,
y.
And then we can then evaluate it from 1 over y to 0. And we sub in x. So it'd be e to the 1 minus 1. Because e to the 0 is 1. Right?
So it's 1, it's 0? No.
No.
It's e to the 1 minus 1, yeah.
And now we take the integral in terms in dy and evaluate from 10 to 1.
Yeah, well, if we take the integral in terms of dy of these things, it just shoves a y onto both of them, right?
10e minus, yes. 10e minus 10 minus.
Wait, does it shove a y into both of them, or technically it's 1 y on the set? Like y times e1 minus 1, since that itself could be evaluated as a constant. Yeah, you could say e to the 1 minus 1 equal to like big C or C1 or something. And then, because that itself is actually a single number, not 2. So we don't want to add 2 y's. It should just be 1 here.
Well, you multiply everything by y. Because they're both constants. And so when you integrate in terms of y, you just multiply both by y.
Yeah. So it's just, and mathematically it still works out to be the same thing. You're right. All right. Well, then doing that is just going to be 10 times e to the 1 minus 1 minus e to the 1 minus 1. So, you do this and you have 10 e to the first minus 10 minus e to the first minus 1, which is actually going to be minus e plus 1 instead. If you flip all the signs on the second quantity, go across and you'll have 9 e to the first minus 9.
9e minus 1.
So the question is.
That is what the back of the book says.
Legend. All right. So now I want to see how big a number that is.
It's a pretty good sized number. It's like 18.
Yeah, it's
9.
like
it's about 9.
It's like 15. 15.46 exactly when I evaluated it. It's a pretty chunky number. I guess that's because the boundary is pretty big. So it goes up to 10. So it's got a decent amount of space, I suppose. All right.
Like it's 1/10 1, and plus it's over a big region on top.
Yeah. All right, that's that. So that's how to do these ones. It's the same process for these. Like you can change variables, you can change order. Just make sure you do the integration part. Now this one changes it up. Sketch the region of integration and write an equivalent integral with order of integration reversed.
That's not too hard.
Yeah, so this is where we start getting introduced to more interesting topics. So we'll just do 5 arbitrarily. So 0, 4.
If I'm right, so we just sketch the region, right?
To start, yeah. So the region here, obviously, you have your Cartesian set, check that, and then you go a horizontal line at y equals 4, and then the x-axis is one of them. And then we have 2 sets where we have that is equal to x, so we can change that bottom barrier to divide by negative, and that will make negative x, but then you square the whole set, so it really doesn't matter. Negative x squared is just x squared because the negative's inside. So it's just x squared is equal to 4 minus y. Reorganize that. Minus 4, rearrange. Then you just have 4 minus x squared is equal to y for our first. That's our lower bound. Oh, you just plug numbers here. You plug in 0, and you have 4 as first intersection. Plug in 1, you have 3. Then you plug it on the other side, just a standard quadratic. So there's that first set that intersects both lines in various places, a couple places. And then the next one, reorganize the top, set it equal to y instead of x. So we have 2x plus 4 equals y. That's just a normal line. So first thing, set x equal to 0. And yet again, you're at 4 intersecting that line ahead and the other parabola. Plug in 1 and you have y is equal to 6. Plug in -1 and you have y is equal to 2. So -1, 2 halfway. So that's so I see so this is in the second quadrant, it looks like.
It does look like it's in the second quadrant.
And it's a interestingly slim zone. So I'm not going to show my doodle because it's garbage, but that's what that looks like. Fun. Knowing that, we have to now reorder the order of integration. So I used to know how to do this extremely well, and now I forget. So I have to look back at something. Let's see. And write an equivalent double integral with the order of integration reversed. So this question right here is literally what we're talking about, just the different limits. So this is what was given. Oh, look, I rewrote it in terms of x and flipped it.
It's not hard.
Here's
Yeah.
my sketch, if it's similar.
Yeah, that's exactly what mine looks like. And obviously the highlighted region is that one little sliver.
Yep. So what we do is we choose whether we're going from bottom to top or from left to right. So from this, it looks like we are going from, what is this? We're going from, I think, bottom to top now, if we wanted to do this in terms of dy. So we go in from the line 2x plus 4.
So we're going right to left.
Just a minute. So no. Yes, we're going from left to right. Yeah, you're right. Yeah. I always have to think about it in the second form, what the second one's doing. Okay, but anyway, so we're going to sum up we're going from the left to right. So we enter at 2x plus 4, and then we leave at, what is this? X squared minus 4, right?
We would leave at yes, x squared minus 4. 4 minus x squared. The signs are flipped.
You're right. You're right.
Yeah, because that negative drops out initially and then comes back later. Oh.
No, we're gonna do top to bottom, or bottom. So it's the same thing though. So this just happens to be the same thing. So what we're gonna do is we're going to say the top integral is 4 minus x squared. And then the bottom one is 2x plus 4. And then
he has a solution for this one, and he actually flips them. 2x plus 4 bottom, negative 2x plus 4 top. So I think I understand how he does this, because then he also has the next limit set as well. So he comes in from the left to the right.
Wait, is this chapter 14?
Yes.
And this is number 1?
Number 5. Is his answer different from the book answer potentially? Our number 1 was correct, as you said.
Let's see. 15, number 5.
14.
Or 4x. No, he's got the same thing as the book. I just don't know how I'm off.
Yeah, so I'm trying to figure it out. So I think the
Wait,
bottom.
No, the book has the opposite, I think.
Interesting.
Wait, no, we all have the same thing. I just am dumb and probably said something wrong. I have the same thing he has, and the book has the same thing as that.
I guess you just said it wrong.
Yeah, I just said it wrong.
So I'm trying to figure out how we're supposed to know this forever. So when it comes to finding the limits, you obviously the most important thing is you sketch it first. I mean, you don't necessarily have to, but then you have to reevaluate the limits that you're given in terms of x instead of y, or y in terms of x instead, depending on how it was initially. And then those functions end up becoming the new limits. You just have to figure out who goes where. So originally, the function that becomes 4 minus x squared is in the lower boundary of the first integral, but it ends up being the higher, like the top boundary in the final integral. And the reason I suspect that is, I guess, is if you go up across that line, if you go up the y, or you go up the, is that the x-axis here? If you go along the x-axis, you hit that first, and then.
So in the original one, the inside one takes it left to right, and then the outside one takes it bottom to top. And then you just take the first two equations, rearrange them to find, and set them equal to y. And then you just find the intersection points and go, well, which is going to be -2. We're actually having good dinner. Pizza. Bill, be quiet.
Yo, pizza?
Yeah, man.
Flexing on me. I want pizza now. All right, continue.
Yeah.
So the main thing to remember about this is that you're going from left to right, and then you're going from bottom to top.
Yep.
That's for dx dy dx.
Which is our answer.
Yes.
Yeah, so you go left to right, bottom to top. And you can see that when you go left to right along the x, you will hit 2x plus 4 first, and then -x squared plus 4. Therefore, your bottom's 2x plus 4, your top's -x squared plus 4. Then when you go, you said bottom to top next then?
Left to right.
Left to right then. So you said, so.
I'm sorry, the dy integral. The dy integral, whatever is the one that's the dy, you're going to go from bottom to top.
Yeah. Okay,
whatever one's the dx, you're going to go from left to right.
Yeah, when you go left to right, you hit the intersection of -2 along the x before you hit the 0, and that's what it looks like here. So that's good. So I'm going to show them what we're looking at right here. This.
Yeah.
More accurately, this.
Yeah. And you go outside.
You go bottom to top. You hit this line first. That goes there. This line next. That goes there. Then you go left to right. You hit this intersection first. Goes there. Next intersection you hit is that. Goes there. Checkmate. You done.
Yeah.
Boom.
All right. That's that. That is not the thing. There's that. All right. So that's how you do this. That's how you do this. What's this? Evaluate. We just did that up here. Did we? Yes, we did. All right. Oh, this is more interesting. This is written funny, but it's no different than like.
It's just 1 over something rather.
Yeah. Look at this. Look at this.
Oh yeah.
Yeah, 3 dimensions. I like them curved. Let's see what we got. Area between line and parabola. Find the area of the region enclosed by the line y is equal to 2x plus 4, and the parabola y is equal to 4 minus x squared in the xy plane.
I like the washer method better.
Screw your stupid washer method. Well, let me take a 2D figure and rotate. No, I refuse to rotate figures. It's cringe.
Just in your mind.
No, it's dumb. All right.
Anyway, so 13 and 15.
So it's doing area and volumes using double integrals. So the area between the line and the parabola. So that isn't that literally what we're doing in these?
Yeah, 13 is the easier one. 15
Yeah,
is
let's do
going to be
15
like,
then.
hey, let's.
I already wrote down that.
Doesn't matter. We're doing 15. I'm sorry, but this is how the world works.
Well,
Disappointment.
13 is just like, hey, let's do what you did, but let's like hold your hand a little bit.
Yeah, literally just give you the
That makes it
functions.
easy.
But we're not here to do the easy. We're here to learn.
I like the
15.
easy.
Yeah. $50.
Everyone likes
He's
the
not even
easy.
gonna give us a volume. He's just gonna give us an area one, and then he's gonna be done with it. All right.
Yeah.
Volume of the region under the paraboloid. Find the volume under the paraboloid given there. X squared plus y squared. Above the triangle enclosed by the lines y equals x equals 0, and x plus y equals 2 in the xy plane. So this is definitely going to be worth a sketch. So we're working in 3 dimensions here. So now you have to draw the super Cartesian.
No, you do not.
You don't have to draw it?
It's the z is going to be the inside function. Since we have z is equal to something, that's just going to be our inside of our dy dx. And then what it's over is going to be our bounds. So you only need to draw the bounds.
Oh, okay. Oh, so this is like, so the volume is these. Technically, this is our
Yes.
inside.
Yes. And that's if in terms of z. When it's not in terms of z, that's when we have to do a triple integral.
Yeah. Yeah, baby. All right, let's go. 15. Now that John cleared that up, we just need to draw our bounds. So there's this double integral, internal function is x squared plus y squared. And we have to set up the order, right? So which order do we want to do it? Just dx, dy?
Sure.
Sure. All right.
No, backwards.
What?
No, backwards.
You want to do a dy dx instead? We can.
I just wrote it in pen though.
No, yeah, we're doing it dx dy.
Too bad.
I refuse. I'd rather die than rewrite it. I use a pen because I don't make mistakes. You see, I write in pen.
Wow, I just got a surface. Get on my level.
How's it a double integral if it's volume?
Because it's given us a function. If it didn't give us this function,
in terms of z.
If it didn't give us this, I think we would have to do the triple. Because look, it's literally this is literally saying area and volumes using double integrals. So we can't even use a triple here.
But the thing is, z, if it's in terms of z, your inside function is going to be the z function.
Mm-hmm.
So, yeah. And then just have it integrate in terms of dx and dy.
Yeah, so let's set our bounds here. So our dx bounds, triangle enclosed by y is equal to x. So we have this, we have x equals 0, which is the y-axis, and then we have another line, which is, it just works out to be 2 minus x. We don't have to do a couple things here, right? This isn't 2 triangles worth, right? Let's think. I'm gonna draw this. So we have the y-axis, we have the y equals x line, and then we have y is equal to 2 minus x. So you plug in 0 and
we have something like that, even though it looks bad.
I think that's fine. I think that's good. I think that's a good triangle. Wait, no. X equals 0 is the y-axis, right?
Did I do that backwards?
I mean, there is another intersection.
Yeah, x equals 0. It's the same thing, but I just am dumb.
I think it's this one.
Yeah, you're right.
That looks good.
You're right. And so in
this
terms
looks
of
suspiciously like a double. I know we did something like this.
So in terms of x, we go from left to right, which x in terms of left to right is 0 because we start at 0. Let's do y. Let's do y first, actually. You guys said that.
Y is better because all your formulas are already in terms of x.
that's not the main problem. The main problem is
You do it in
if we wanted
DX, there's two. Yeah.
yeah, we would have to split it up into two, and I don't want to do that.
I remember doing that. That's why I said it. We have to do two of these in a second. All right, looks like Ryan and Jeffrey were right. Rip. I now made
They
a
win.
mistake. My first official mistake in pen. All right, let's go. Find the volume under the
It's technically
paraboloid.
not a mistake. We just made a choice that
We made the wrong choice.
we made the wrong choice. Anyway,
Alright,
so
try.
from top to bottom, we hit first the y equals x, which is the equal to x. That means our lower bound is x, and then we get out at 2 minus x, right?
Yeah, y equals x is lower.
Yeah,
Wait.
yeah.
So it's x lower and then 2 minus x upper.
2 minus
Then
x.
from left to right, it's from 0 to 1. Yes.
Mhm. Correct.
Easy.
Of
And
the
then we
internal
just-
function.
Is x squared equals
If we do y cubed over 3 plus y times x squared,
Mhm.
and then evaluate the integral. That's x cubed over 3 plus x cubed.
Ah,
which
but
is-
2 minus x times x squared.
Yes, I did.
So you have
The
x
bottom one first,
cubed
I don't know.
over x cubed over 3 plus minus, I should say, x minus x cubed
Sorry, I
plus
don't like
2x squared.
2 minus x cubed. That does not spark joy.
Well, 2 minus x, and then you times it, and it becomes 2 squared. 2 squared, 2x squared plus, or 2x squared minus x cubed, which is just, it's just a polynomial. Let me just evaluate across the board at
Not
x.
a polynomial, it's a trinomial, isn't it?
Yeah, whatever it is. It's just a function. That's pretty easy to just do the integral of, because then we integrate it again. Then we have
Oh yeah, because it's okay. Never mind. We
x to
don't
the
have to expand it.
4th over 9 minus x to the 4th
2x.
over 4 plus that's an easy one, just 2/3 x cubed, and then evaluate from 0 to 1. So 0 cuts everything out. Evaluating at 1 is 1 over 9 minus 1 over 4 plus 2/3. And that's 19 over 36. Let's see if you worked this.
For 14, which one?
15.
Yeah, 14, 15. 4/3.
Whack. I got 19 over 36. Wait. Bruh, he wrote it down and then didn't finish. I guess he just assumes we can evaluate this without making a mistake.
Or
It looks like
we
I made a mistake
Oh.
somehow with 19 over 36, so let's think.
integral calculator here. Let's go.
Timbo lab.
Did anyone else get 4/3, right?
Just a minute. I
Okay.
didn't work it because I got a nasty equation, and I'm like, I don't want to.
I didn't work it because I'm eating.
Legend. What are you eating though? What is that?
Big ZD.
Bruh, he's flexing on us. Ryan, does your pizza stack up against his big ZD?
Bro, I hadn't even gotten it yet.
Rip, dude. I haven't gotten it yet either. I'm gonna request. I would make a DiGiorno, but that requires me to go somewhere. That's the first time. I think that's the first time Jeffrey's turned on his camera, actually. I don't
No,
remember.
Jeffrey did
I don't remember
it
if you ever
a
turned it
couple
on.
times. Not today.
I obviously wasn't paying attention.
I think I did the first few.
Probably. All
Well,
right.
the integral calculator said that I got the right formula.
What does it look like to you?
So what I got was -7/3 x cubed plus 2x squared plus the quantity 2 minus x cubed over 3. And that's the integral from 0 to 1 dx.
Yeah, you're probably right. I just realized I made a mistake.
So something like this. The last line is what I got. And integral calculator said that gives us 4/3 when evaluated.
Yeah,
However,
that's correct.
I didn't want to do that because of the last one. I don't like the last one. I
What
can
does
do
the
it
last
because
one say?
the last term is the 2 minus x cubed over 3 term.
It's not the worst. It's just chain rule, but it isn't. Well, it's not just chain rule, but it's reverse.
I have
chain
to
rule.
use it's either u sub. You have to do u sub on it technically.
Dude, real gamers just assume that it was done. You just figure out what you have to take the derivative of to get it.
That's how I do it. But
Yeah.
it takes brain power to do that.
Yeah. All right, let's see. Polar coordinates. Skip. All right, let's get. No, we're gonna have to
Polar
touch on.
coordinates are fun.
Yeah, it
Let's
showed
go.
up. I know it showed up on the exam, so we're gonna have to do this here. Change it to polar, gang stars. So what is it? So the rule is what? R is equal to what? And X and Y are
X
equal to
squared
what?
plus y squared. X
X
is equal to x is equal to cosine theta.
cosine theta.
R
and
cosine
Y,
theta. I'm sorry.
R cosine theta, and then Y is equal to what?
R sine theta.
Yep. All right.
All the real gamers.
Let's go. Let's see. Did he? He did 19, so that's cool. So we'll actually have an answer,
yeah.
hopefully. So this is this. So let's change it to polar. So looking at these questions, what's the step? Do we change the bounds first or the function?
So let's change the function.
All right.
It doesn't matter.
Oh.
Oh wait, no, we need to find what the circle is because we need to find R from the graph of the function.
Ew. All right. Well,
So
in doing so, I can tell that, it's negative y is squared. So we have a y squared.
So it's
plus x squared equals 1. The radius is 1.
Yes. So R is equal to 1. X is equal to cosine theta now. Y is equal to sine theta.
Oh, I see some simplification.
And then x squared plus y squared equals 1. So what we can say is the function is now 1 plus 1, well, 2 over 1 plus 1 squared. So it's 4 squared or 1/2.
2 squared, which makes 4. 2 over 4, which is 1/2, which is, yes, there you go. So we have 1/2. Well, it's 1/2, and then what? We scale the dy and the dx. So what do we do?
R dr theta. That's 1/2 R dr theta.
Yeah, and then we're gonna go 0 to 1 and 0 to 2 pi, right?
Is there a 1/2?
Yeah.
I thought translating to polar coordinates is just R dr theta.
You have to convert the main function to.
And then that's
so we're just talking about this one. Okay.
So for 19, yeah.
We're supposed to multiply by R, aren't we, though, when we do that? But since
1/2 R dr theta. So we're given 1/2 R dr theta, and then.
But R is just a 1. Well,
yeah, so R is from 0 to 1 because we start at the origin and then we go out and then we hit a radius of 1. And then since it's the whole circle, we go from 0 to 2 pi.
So those are limits. Now the function is, so this is the limits of 1/2 R dr d theta.
Yep.
And then the R is just 1/2, or is 1, right?
Don't do that now. Now you have to do the integral.
Fine.
So you have to do the integral in terms of r of 1/2 r, which is simple enough. It's 1/4 r squared.
Yes.
Evaluated at 1 to 0, which is going to be 1/4.
Correct.
And we go from 0 to 2 pi of that, which
Evaluate to theta, and
d
it's just gonna
theta.
be 1 pi over 2. It's just pi over 2, right?
Pi over 2 minus 0, which is pi over 2. And that is for number 19. And
He has that solution.
19 is pi.
Bro, does this man even do it?
Nope.
Legend. Was it pi over 2?
Yep.
Awesome. That's all I want to know. Yay.
Wait,
Let's
no,
hope-
19 is pi.
What happened?
What did I do? What did I do?
Well,
What?
so the RDR is correct.
Did I
So that would
do
spit it.
done?
Yeah, so you do that, and it's divide. Yeah, it's divide by 2. So yeah, so it's gonna be 1/4 r squared dr, and then evaluate that, and you will have 1/4 and then 0. So that goes out. Then d theta. Are we
I
sure
think I
it's the?
know what I did.
Are we sure it's the full circle? Because if it's not, then obviously it would.
It is the circle, but when I just did the, just keep it as 2r dr theta over 1 plus r squared squared.
What? What?
So what I did is I assumed incorrectly that we could say x squared plus y squared equals 1, or we can't say that.
Why
We're
can't we
gonna
say
put
that?
cosine.
X
We're
squared
gonna
plus
put
y
cosine
squared
in it and then
equals
sine theta in.
r.
So we're gonna
You
get
can-
cosine squared theta plus sine squared theta, and that is 1, isn't it?
Well, it's technically equal to r.
X equals r cosine theta, y equals r sine theta. We can't say that r equals 1, and I made that mistake. You can only say r is equal to 1 for the bounds, not for the function.
Well, does that actually change anything? Because we didn't
Yes.
plug in 1, did we?
Because in the denominator of the equation, it's 1 plus r squared instead of 1 plus 1.
Oh yeah, now I see. I get it now.
So
Yeah. Yep. 1 plus
I
r.
would simplify this 1/2 dr d theta.
Well,
right?
isn't it technically 1 plus r squared instead of 1 plus r squared? I mean, it sounds like I said the same thing twice, but it has 2 different implications.
it's 1 plus r squared squared.
Like all squared, yeah.
Yeah.
Wait, 1 plus r squared squared or 1 plus r quantity squared?
Quantity 1 plus r squared, quantity squared.
What?
Wait. It's
So
1
so
plus
so
r
x
squared quantity squared.
so x squared plus r, so x squared plus y squared is equal to r squared then.
Mhm.
Yes.
Yeah, that's what I thought actually. All right.
Yeah,
Cool.
I just
Yeah. So
did
working
poor
that integral changes the game a little bit.
yeah, it's a lot harder than the one that we had to solve. It's not a lot harder, but it's hard enough. U equals to 1 plus r squared. Du is equal to 2r. Simple enough to just say 1 over u squared.
I don't want to do
du
freaking u sub.
d theta. Well, it's getting to the time of year where we don't get to pick what we want to do.
Yo, gamers, how do we do this one?
U to the -2, what's that? U to the -1 times -1. So it's -1 over u. Evaluate from 2 to 1, which is -1/2 minus +1, which is 1/2 minus a -1, which is +1/2. Evaluated d pi to 0 d theta. Okay. Yep, and that gives us the right answer, by the way.
Cool.
Nice. Look at this. Look at that word. All right, we're done with that. All right, triple integral time. It's almost gamer time.
For anyone who wants to know, that's my work on that.
Legendary. That's some integration right there, is all I gotta say. All right, we'll just do, both these are the same, so which one do we want to do? Do we want to do a cosine, or do we want to do a,
For which one?
23 or 25, which do we want to do instead? Which should
Did
we
he
pick?
do one and not the other? No.
They're both, like, they both are the identical process. It's just a matter of which one do we want to integrate over and over again.
Yeah. I don't have a preference. So,
Yeah, it looks like it just ends up finishing itself pretty quickly. It's gonna be like 3 pi or something. All right. Cosine at 3 pi or something. Let's see.
Wait, so what are we doing?
We'll just do 23. This is the first one that shows up.
Okay.
So it's 0 to pi 3 times over, which is hilarious.
Nice.
So this is the proper method of volume when not given a function defined as z.
And as always, we're going to treat everything else as a constant and only integrate. Okay, so then we're getting integral of cosine as sine.
Oh, ew. This is so much longer than it has to be.
So much integrating.
Oh yeah, that's great. This ends up with so many functions. Oh yeah. Yo, anyone finish the daisy chain yet?
Just a minute.
There's
I'm on the last one.
There's does it reach 6?
6 cosines. I'm not there yet. I'm up to 4 cosines. Give me a minute.
Oh my god.
Do you want to kill yourself yet?
Dude, there has to be some type of like weird obscure identity that if you integrate over the same bounds of an oscillator, like a function like cosine or sine that flips between like a set state of values, that has to like create some relationship. Like there's no way that this is there's gotta be something. Obviously we don't know it, but like there's obviously a pattern here.
Integrate cosine, which is sine.
Yeah,
Yes.
if it's a positive cosine, it's positive sine, negative cosine, negative sine, negative sine, positive cosine, sine is
I don't think of it as like that. I just take out the negative and only treat it as positive all the time.
that's pretty cringe.
It says I only have to memorize 2 identities though, and you need to know 4.
I suppose.
Come on, real gamers.
Oh, cool.
We really should have done 25.
I picked this problem.
Technically, can't you combine the middle two? I think
As long as they have the same, yeah, there should be parts where they start having
cosine
the same
pi
stuff.
plus z plus cosine pi plus z.
Yeah, it's just 2 cosine pi plus z.
I'm already way past that point, so let's keep on going. Okay.
Eventually, it'll just be a bunch of trig functions evaluated at integer multiples of pi.
Negative sine of 3 pi plus sine of 2 pi plus sine. Wait, isn't this all 0?
Yup.
Yeah.
No,
Yeah.
no.
Yeah.
What is it? What is this? 25? No, 23.
Yeah.
Bitch, it's 0.
Yeah.
0, boys.
I just wasted a couple minutes of my life.
Do you guys
I
want to
got
see?
halfway and then I realized it's gonna end on sine, and any sine is 0 at any integer. And
Do you
you
guys
said
want to see
it's integers of pi.
you guys want to see the shortest ever officially published and accepted mathematical proof?
Sure.
This is it. That's all it is. Legend.
I don't know
This-
what this is.
It's just the shortest proof. It's just the record for shortest proof. This right here is the video
Oh.
that I watched in order to like learn about this. It's really funny. There was like a competition, just like people started out playing each other, and then these guys won it.
Wow. What a Chad move. Anyway, let's keep on marching on. Let's hurry up.
Bert,
Finish this.
Bot, it's dinner time. All right, we did that already. We could jump back up here. There was not a single question here that he asked. Rectangular to cylindrical coordinates. What?
Garbage.
Do we even do? Have we even done this like cylindrical and spherical? I don't even remember doing it ever.
Spherical coordinates is that one with the little weird thing.
How or something? Isn't it?
How
The
that's
phi, phi, whatever.
yeah,
It's
phi,
probably-
phi, theta, and r,
That's it.
r, theta, phi.
This is test 3. This is what should have this topic. Let's see.
It doesn't. We never had a question about phi.
Let's look at test 4 as
But he
well.
literally said he wasn't gonna put it on the test.
Yeah.
For that
Yeah.
test.
He's not gonna,
Because
if he didn't put it there, he's not putting it here. No way. Boop, boop, boop.
He say that, and then there's gonna be 2 of them.
I don't care. I couldn't care. I think I need a 70 to keep it. I really don't care. All right, let's go. This should be
I need a 74. That's it. Just
You
a
need a-
74.
74 and it's game on. Yeah, it shouldn't be too hard. All right.
74, I'm good.
Yo,
I should calculate that right now.
that's one hell of an apple if I've ever seen one. All right, let's keep going. We've reached the legendary chapter.
All my homies hate line integrals.
Look at all this, how much there is.
Look how much he hasn't circled until like the next
Let's
page.
literally we'll do this one and we'll do like 3 of these. We'll just pick arbitrarily, we'll do like one of these, like one of these, or like we'll do like one, this, and we're done. I don't even think we have to do flux. Actually, no, flux across the surface is a good example. Either way. Let's do this one because I know this one's not the worst in the world. Line integral time. Oh, actually, we haven't been looking at this. Let's go down to. He has a lot of stuff. Oh, he just gives you all of this. Legend. Line integrals. What? Okay. I just forgot what that is. So. Line integrals of f of x(z). Line integrals, I guess this is of a field or something. Oh well.
Yeah, that's what it looks like.
Well, this is the easier one, it looks like. So we'll start with this one. The accompanying figure shows 2 polygon paths in space joining to the origin. Integrate that function over each of the paths. So what's the proper maneuver to do these? So we just saw a formula, but the formula is a little complex. With that, a little bit of background.
I forget how to do line.
Yeah, so this is the basic formula, looks like. So it's f of x evaluated at t, y evaluated at t, z evaluated at t times the magnitude of v of t. What the heck is v of t?
It looks like it's.
Well, looks like it's time to go look at line integrals I did. This is test 5 topic.
Oh, we're looking for like RT, and then we're going to take the derivative and the magnitude of RT.
It's the
RT.
It's the unsolvable integral problem.
Yes, sir. He was like, yeah, it's fine, just do that. And it's like, no, we really can't.
All right.
Do it.
Because like, so so in this, the path 1 is going to be R, which we can easily see is going to be 1, 1, 1. RT is going to be 1, 1, 1 because it's from tip minus tail, which 0 to 1, 1, 1, 1 is going to be
T
1,
is
1,
equal
1.
to I plus J plus K. Cool.
So that means
Then we have to do V of T.
Which is 0?
Yeah. I think so, because it's just the derivative, right? Magnitude of the derivative.
There's no.
Wait. Isn't this gonna be like TTT then? It's 1, 1, 1 coefficient. Let's look. Let's look at this. So this is from 0 to t to 1, and then this is the function that was given: x squared y root z.
And now we need to. Oh, it's just gonna be. Is it gonna be 0?
That's what we're thinking, because so the t comes from the path of r then, or the r comes from the given path on our polygon.
Is it gonna be ti plus tj or plus tk, or is it gonna be?
That's what I'm thinking. I think it's like
that's yes. Yeah.
That's what I'm thinking. Because these so like when we're constructing vectors like that, these numbers are coefficients on t's. So
and then t is going to be from 0 to 1.
Cool.
That's going to come back later, I think. Maybe it doesn't.
Then obviously v of t is just going to be I plus j plus k then.
Yeah, then we gotta take the magnitude. So it's gonna be like a square root of 3 or something.
It is root 3. And then we have the magnitude, and then it's the magnitude times whatever this is, which is evaluating each of the functions at t. It doesn't even look like we.
So, well, yes. So basically what that's saying is x of t is going to be the I component of our path.
Yeah.
And that's going to be in terms of t. So in this case, x is going to be t, y is going to be t, and z is going to be t. X of t. X of t is t.
Yeah.
So it's gonna be
2t minus 3t squared minus 2t plus 3 all times root 3.
Yep, I'm gonna just pull out the root 3 and just leave it out.
Yeah, that's what I'm doing. And then we have to integrate. Is this from 0 to 1 then?
Yeah.
That's our boundary of t.
Yes.
Cool. 0 to 1. Integrate this from 0 to 1 isn't that bad.
No, it's not bad at all.
No, the fractions all get canceled out.
Negative 3t squared plus 3.
Oh, 1 minus 1 minus 1 plus 3 minus 0.
It looks like it ends up being 2 root 3. Yeah.
That is the answer in the back of the book. So
gamers. All right, cool. Hopefully he just gives us this again, so we just get like 3 points or something.
So remember, just a
questions.
Oh yeah, let's look at the breakdown again real quick. Did I have that open still?
It's 15 is 30% of the test.
Yeah, I think I closed it. So it's kind of nuts that this chapter's worth 30%, but 30 points, but yeah, which is still
11 and 12 is 35. 13 and 14 is 35, and then 15 is 30.
But by nature of this one chapter being worth so much, it's obvious that we'll get like It's 3 questions, right? He said 3 questions, so we'll probably get like one of these, one of these, and like one of these. Probably won't even do a simple line integral like this. Probably do a more
Oh, we
complex
can
one.
hope.
Yeah, we can hope, but hope isn't helpful. This would make Da Vinci happy. This figure right here. My man thought this would work as a helicopter.
It
Oh well.
wouldn't, but it's
Oh.
okay.
Why don't you try it and see if it works?
So many people have built like scale models of Da Vinci stuff, and it's straight up a 50-50 of whether or not it would work. There was I think it was a Persian king who contracted Da Vinci to build a bridge, and Da Vinci designed a bridge. And at the time, if the king had the emperor, or the whatever the proper title for Persian king is, I used to know it.
The dude.
Yeah, I'll just call him the dude. Either way, if he had gone through with the plan that Da Vinci wrote up, it would have been the longest bridge at the time. But the king thought it was impossible, so he didn't give him the contract essentially. And later on, I think it was MIT students reconstructed the bridge with Da Vinci's designs at the exact size, and it worked flawlessly. Legend.
Nice.
Yeah.
What a G.
I love Leonardo. Absolute baller. All right, let's do conservative field question. Let's just arbitrarily pick 32.
32.
Do we want to do 32? We don't have the answer for that.
Oh damn. Do we have an answer for any of them?
Wait, we do actually have.
I think,
Wait.
right?
Yeah, we do have answers for odds, and that's the main thing. Did he do 35 and 36? Yes, but yeah, let's do an odd problem. We can do whatever you want, but let's do an odd problem.
Oh, he's got 33 on there.
Does he have 33? No, I think that's for chapter 14.
Yeah,
that's for chapter 14.
This is all he asked for 15.
What the heck? And that's worth 30%?
Yep. He got tired at the end, probably.
As we are probably getting tired. All right, either way.
Let's finish out this chapter so we
do 29 then.
Let's just do 29 then, since we don't have the answers for any of them.
Yeah.
F.
Well, we have the answers for odds, but
yeah. F is equal to xi plus yj plus zk. So let's take a peek at his final review sheet and see. Conservative vector fields. Conservative means f has a potential function. If conservative, use the Fund Theorem of line integrals. So in order to test if this is conservative, we just do this?
Nope.
No, that's if it's conservative.
How do we? Oh, we have to test for path independence. Is there a way to do this?
Yeah, it's with the, I think, isn't it like each partial has to equal each other?
Yeah, something like that.
I got you, man. Let's look at the formula card.
I think it's like partial of m with respect to something.
That's it. The top right.
Yeah.
This?
Yeah.
That's
where do these come from?
The x part and n is the y part, and then p is the z part. The k part, I guess.
P is the z.
So like p is your little k component over here.
Yeah, so let's write down these identities. So the first one, the partial with respect to big M, partial with respect to y is equal to the partial with respect to big N with respect to the partial. I guess that's x, because my handwriting sucks.
Yeah, it really doesn't matter what. All you're gonna do is you're gonna check to see if all of them equal each other.
All right, so I can tell you that this is conservative.
It is, because everything's gonna be 1, 1, 1. Yeah.
You just take the partial. Yeah, partial with respect to x is equal to the partial with respect to y. Yes. Partial with respect to y is it equal to partial with respect to z? Yes. Partial with respect to z is equal to partial with respect to x? Yes. You're done.
Yeah, that's easy. As long as you just have those little.
Yeah. As long as the functions like fit and work, it's gamer time. So that's what conservative.
It's either going to be 1 or 0. I forgot. If you don't take it, if you take m in terms of x, it's going to be 0. But anyway.
Find potential functions now.
I think it's still going to be conservative.
So to find a potential function, let's look upon the mighty formula sheet. Is this it?
Potential function is the guessed correct thing, right?
What?
Oh yeah, Jeffrey's gonna be a G and just look at the function and tell us.
What was the process for potential function?
I have no idea.
Yeah, all right,
You
let's look at it.
kind of just look at it and go
Boom.
like, "Yep, that's
What
it."
is the potential function, Jeffrey?
But in all seriousness, it's the one where you take the integral of each subpart and
Is it this?
so if you look at
Is it
go
this?
back to the question. So you integrate I in terms of X and then plus C, and then you integrate J in terms of Y and plus C, and then
I
K
hate
in terms of Z and B plus C, and then you're trying to find what's the common thread.
So we're integrating each of these?
I hated this.
If you don't want to just guess and check.
Jeffrey, what do you think it
So-
is?
Well, there's a 2x piece. There's going to be a y squared piece. A zy piece,
So if we're doing 33,
and I guess a z.
So your guess is
2x
2x
plus y squared plus yz plus z plus c.
Z plus, what happened to the plus yz plus, shouldn't it be 2yz then?
2yz.
It's gonna be
Because
a
there's
ZY.
another zyyz, but those are the same. So it should be 2yz and then plus z. Do we have answers for this somewhere?
It's an odd, so we should.
Yeah. Obviously not in this, but yeah, no, I think it's 35 use these.
so what I'm
No.
getting
This is right.
y squared plus 2x
Mm.
plus yz
Mm.
plus z.
Plus z.
So there's no
Or any
2yz.
constant.
So on this then, when we did the integral with respect to y, this brings a yz up. But then over here, integral with respect to z, this doesn't matter then? This doesn't become?
That's the yz term.
So we have a zy and a yz?
They're the same thing.
No, they're the same thing.
So it's 2yz. Or we just
No.
leave it?
Nope.
Do we just
You're
take
trying
one
to
of them?
find what all the parts that form together. So like if you look there, the bottom is my function. That's the potential function.
Yes.
So what happened is we take the partial in terms of x of this function and we get this. We get this. Then we take the partial in terms of y of this function and we get this. We take the partial in terms of z, we get this.
All right, easy. A great way to test for it. So you simply integrate each component part and pull the thing that's, important from it.
Mhm.
Sum them all together.
Yeah.
And then you test back with your solution to see if it's equal to the partial derivative of x,
Yep.
y, z with respect to itself. All right, cool. So it should equal its own gradient. Or the original function should
Yes.
equal the gradient of the potential function. Cool.
Yeah.
Yeah, that's what
Yeah.
that is when you take the
Is it
partial. of each
gradient?
component.
Yes.
Yeah, because that
Yes.
forms a vector. All right. That's 33 and 34, same process. Work in circulation.
Those are nice.
Yeah. So do we want
Do
to
you want me
do
to send the sketchy PNGs again?
of what?
Remember last time when
look at
I
those.
just
No, I don't want to look at those, dude. That's a
where
virus.
I just sent math.png?
I guarantee that's a virus. No way in hell. Not happening.
Bro, I sent math.png and it
That's
was
sus. That's sus.
it was like the curl integral
Look, it's green.
and then the other one.
It's green serum.
Yes, it's green serum.
Alright. Let's look at this. Work in circulation. Let's just do this one. 35. F is equal to 2xy on the I plus j plus x squared k. So what do we do? It's along two different paths.
Work equals force times distance. So if we do work is equal to 4 dot distance. So we do the dot product of the force and the path.
That sounds right. I think there's some weird formula for this in the book. I'll look it up.
So looking at this, if we're doing that, then the path from 0, 0, 0 to 1, 1, 1 is simply the magnitude of a vector formed between the points. So it's tip minus tail. So it's just going to be 1, 1, 1, obviously. And then take the
Yep.
magnitude of that, it's going to be √3. So that's the magnitude, but we want to form a vector instead. Should we just dot it with the vector I plus j plus k? Well, I don't think we need the magnitude at all.
I think what we do is we do the line integral over the function, and we have to parameterize it. I think it's just a line integral. I honestly think it's just a line integral. Let's see. Let's find out.
Well, I mean, you technically did these ones. Find work along two different paths. A 35 is not conservative, so must compute the line integral over both paths.
What he's saying is that there's two different paths, but they're the same. They're the same. They're over the same path. So if it's conservative, meaning line and path independent, you could go any way you wanted to.
Yeah, but because
true.
if it's not conservative, that means each of them have different values then.
Correct.
What are we trying to do?
I can't find the weird work formula.
This looks like it. This looks like it's the Fund Theorem. So if it's conservative, it's the Fund Theorem. So it's this thing.
Yep.
F dot t, which is.
That looks like it.
Wait. So that just means what? So it just ends up being the function at b minus function of a. Then that's it. We don't even need to actually do this. Let's see.
Well, yes and no. So basically, we're going to find the potential formula for this and then plug it in from b to 0.
A. Okay, so let's find the potential formula then. Observation time.
Potential function.
All right, so we have an x squared, a y, and a z times x squared plus c.
So we're given
So we have what? So is it 2x? Yeah, it's x squared y plus y plus x squared z if we're looking for the potential function.
No, we can't have that. Wait, what? What?
35 is not conservative, so we actually can't do it that way. I just realized.
Wait, but if we go back to the solution, what?
He didn't even do 35.
Yeah, I did.
He just said it's not conservative, so you have to find two different paths. And then he did 36, which is this.
He did, which is actually solvable.
Yeah, this one is just doing the line integral. This one
I believe
is finding the potential function and then evaluating it at this, b and a. So tip tail. And let's see what his potential function was. The heck did he do? X squared plus y plus y. Did he mean to do plus yz here? No, plus yx squared, it looks like. I don't know what he's trying to do there. Jeffrey, what do you think the potential function is for 36? We have x squared y.
Yeah, x squared y plus z.
Yeah, that fits most likely. Because when evaluating, this is going to spit out 2 when evaluating at 1, 1, 1. And then when evaluating at 0, 0, 0, it's going to spit out 0. 2 minus 0 is 2, and that was his answer. So that's all you do. Find the potential function, and then evaluate. Yay. And then if you want to do and you need to know if it's conservative, because this field is non-conservative, therefore you cannot do it using Fund Theorem. If it's a non-conservative field, you simply have to go back and use the method of line integrals that we used up here and just do it along 2 different paths. In this instance, luckily we have the same numbers in that question as this question right here. So your 2 separate paths is the direct line right here, and then the this way. Well, technically it's this way, this way, this way.
Right next to it is the other way to do it.
Yeah.
Path 1 and path 2.
Yeah. Oh, he still did it like 2 ways. He moved in along a plane here and then went up an axis. No, we gotta go down. All right, we did that.
I'm gonna do 49.
49.
And then be done.
I suppose. I mean, there's also the flow thing.
We could do flow.
But let's see. Wasn't flow like really easy or something?
Yeah, I had like an easy formula or something.
Yeah, where is that? Well, I'll check my personal note card here.
Database.
Did I have flow anywhere? I had work equals this, but I didn't.
Circulation is flow, isn't it?
I think.
There's flux and circulation. I know those 2.
Yeah, flux is what 49 is about. I think.
Yeah,
So,
I mean, I think flow is the same as circulation.
No, I don't think so. Wait, you're not Ethan. You're not civil. You don't have to know this.
Circulation is flow
Doesn't matter.
equals work equals the dn dx minus dm dy. And then flux is the dm dx plus dn dy.
Wish I could have him as a note card.
This. Is this flux?
That's your form for your function.
Is this flow?
Your flow is the thing below it, the dn dx. Yeah, that's your flow or circulation, also work. And your flux is a dm dx plus dn dy.
So it just changes
to
this?
the right of your formula. Like go up and right.
Yes. I wrote.
Yeah, that's flux.
I wrote flux in terrible handwriting. So there are the formulas. And this is just the double integral of the partial with respect to the x term, partial with respect to the y term, and then integrated across bounds. So let's look at this and see what it's about. So the formula we have here, we'll just do 38a for flow. The formula we're given is x squared z e to the y. So using the formula for flow, which is circulation, which is this one, we do the double thing, and then we have its partial x minus partial y. So once around the ellipse in the plane x plus y plus z equals 1, which the plane x plus y plus z equals 1 intersects the cylinder from is viewed from the positive x. So this is just to draw our limits of integration. So I'm gonna occupy myself with that after I do the partials. So partial with respect to x here is just 2xi minus partial with respect to y, which is just e to the y still times j. So it's 2xi minus eyj. Now our limits here are going to be a bit tricky because the question asks it in a weird way. Once around the ellipse C in which the plane intersects the cylinder. Awesome.
So hear me out. Let's subtract 1 from each side on the first one, subtract 25 on each side of the second one, and then set them equal to each other. That should give us the plane.
You mean the limits?
Well,
Because
first,
it gives us a plane and a cylinder, and we're looking for the ellipse's limits that is formed from the intersections. So I don't think it's possible to solve here with just that, because we'd have to parametrize a variable since we have 2 equations and 3 variables.
so ideally, it's actually we're just given one plane. And that plane is where they intersect. And we know when they intersect by if we set them equal to each other.
Yeah, you're right. It would form. It should theoretically have 1 dimension. I don't know. We'll see. Because the cylinder.
It should be flat 2 dimensions, but yeah.
Yeah, because the cylinder x plus z, x squared plus z squared is just going to be, a cylinder along. Yeah, as viewed from the positive x-axis. So looking down on the cylinder, it's a circle. And then with a radius of 5, right? And then
Yeah.
the
So
plane
it's like what if we
intersects
cut
with
the
it.
can if we like cut the can in like half, like an
Yeah,
angle.
yeah,
It forms an ellipse. 2D ellipse. This is above my pay.
No, but it says as viewed from the positive x-axis. So looking down.
Positive y-axis.
Yeah, by positive y-axis. Looking down through the cylinder, shouldn't it still be a circle?
You're cutting it at a slant.
Yeah.
Well, yeah, they're gonna have a third thing. Oh boy.
So there's going to be something that's closer to you that's going to, and then something that's farther away.
So I believe we simply disregard. We have to disregard a variable, which I feel like it's going to be y here. Although, no, it's not true.
I
Because it's going
don't
to
think
be
we
slanted.
disregard it.
All right, let's set it equal then.
I think we have to set it equal.
X squared plus z squared is equal to 25. No, minus 25 is equal to x plus y plus z minus 1. So. Oh boy, I don't think it's possible to do this one. Let's see.
So we got a plane now. So what do we do with that?
Who knows?
I don't want to do this one.
Yeah, this
I just
one's
figured out
really.
what it is. Oh, it's something with polar.
Oh, never mind. No, let's just we'll just say no and say go to B along the curved boundary of the helicoid in exercise 27. Screw it, we're not doing flow. We know the equation. Hopefully it doesn't give whatever the hell that is.
So what 38 is, what it's asking is we're given an ellipse and we have to find it in terms of R, because once around the ellipse is going to be from 0 to 2 pi. So now we just need to find an ellipse in terms of R to figure out the integral. Yes, Ryan?
Nothing.
Okay.
Yeah, that sounds entertaining, but we could just do flux and be done. Potentially.
So basically what we're gonna do is we're gonna pray that it's not on the test and then cry if it is.
It's not. There's no way in hell this type of question. We know the formula of flow, but these things are kind of nutty because you need to know a lot of background knowledge.
I just need a 74.
Yeah, it's only worth 30 points.
I need a 65. Let's go.
God damn, Jeffrey. All right, 49. Let's just do
I think I'm in Jeffrey's vote.
Do you want to do the square or the triangle?
Square sounds easier.
I mean, you're right. Isn't it just like 0 on a square?
Flow is 0 on a square.
All right, we're
Flux
done.
is different.
No, let's just do 50.
Wait, is it actually 0?
Yes. I remember that. It's like always 0 or something.
Yeah.
Why do I know that?
All right. Square or triangle formula. F is equal to y minus 6x squared I plus x plus y squared j. Cool. C, the triangle made by the lines y equals 0, y equals x, and x equals 1. So literally the x-axis. Wait, no, the y, nope, there are no axes here. All right, wait, yeah, there is. Y equals 0 is in fact the x-axis. Then we have y equals x, which is the, 45-degree legendary line. And then we have x equals 1, which is a horizontal or
Guys, it's
vertical
not
line
0.
of the square.
Yeah, 49 is not 0.
Crap.
What
That's
is it?
49
flux, not
is
flow.
negative 1/2. Circulation is negative 1/2. Flux is 3/2.
Oh, well, we just have to find the flux here. So let's look at the formula for that, which I have. Right
It
here.
asks for both flux and,
Oh, this does?
yeah.
Ew. Well, we would just do the formulas, right?
Yep.
This one and this one. And then obviously this, the R on both is just going to be given by the bounds. Which here we have a nice right triangle. I have a question. Why don't I see any Jacobian stuff anywhere?
No,
This was a lot, okay? This was a lot of stuff, and this man just like
yeah.
no
And
Jacobian.
then TMB planes or whatever it is. I don't think that's on the test either. Like that stuff was whack.
Just put algebra on the test.
All right, so let's just do the if you wanted a triangle, just keep going with the triangle, just because it's the same process as square, it's just different bounds.
I already wrote the stuff down.
Yeah, but we don't know the answer to 50.
Shit, you're right. All right, fine.
Okay.
Square it is. F is equal to 2xy plus x times I plus x, y minus y times j. So knowing the formula for circulation, which is right here, circulation, it's partial x minus partial y integrated over the barrier or the limits. So starting and doing this, we do partial of the x, which will spit out 2y plus 1 times I plus partial with respect to y, which will spit out x minus 1 times j. Okay, and now we have to double.
Wait, is M the first one or second one?
See, it says like we say M, but it's N when we start.
Okay,
But,
so it's N in terms of X.
Yeah, but what is
right?
N and M? Like, what are those even defined as?
The one right above it.
M is the I component and N is the J component.
Yeah.
Oh, ew.
Ethan, like literally right above your cursor.
Yeah, I see it. That's cringe. Well, flip it. Instead, we're gonna have the double integral
2x.
of
2x. And then
will it be 2x? If
Will
it's
it?
if n is the j component in our f that's given, then it's xy minus y. You take the partial with respect to x of that, and you just get, y minus 1.
nope, y minus 0.
Yeah, you're right. So it's just y.
Yeah.
Yj and then yi. All right, and then the next step is take the partial with respect to y of this, which will spit out 2y.
And then we just need the bounds.
Yeah,
2x.
so the bounds, you said 2x? Yep,
Yeah.
2x.
That's it.
Yeah,
2x
now the bounds here, what order should we, it's dx dy.
It's either or, it doesn't really matter.
Yeah, so the limits on our x is 0 to, I believe it's 1. Wait, where's that horizontal line at? Yeah, if it's at x equals 1,
Both
it's
0 to 1, that's nice.
The one before it. Yeah, but yeah, make sure you're looking at the right one. It's 0 to 1, 0 to 1 for both.
Yeah, it is 0 to 1, 0 to 1 for both. All right. So when we do the integrals of this in like vector form, we just do the integral of each, right? It doesn't matter. with respect to
Makes sense.
x. Like it would spit out. You do this, and this is going to be, with respect to x, it's going to be yxi plus 2x squared. Well, it's going to be 2x squared over 2. It's going to be x squared j. And then we evaluate that 1 to 0. So obviously the 1's just going to be y again.
So 1/2 minus 1 minus 0 minus 0. So negative 1/2.
For circulation, and that's what we got for the answer.
Yep,
And
that is
then-
the answer in the book.
And then the last thing is to
It's
find
flux.
the other formula, which is given right here, which is the m component. So this is where I like fully defined all of them, it looks like m and, well, this is m and n, and then obviously p if needed, but we don't need it for these. So m.
What was the answer?
So this time you do it proper. You do it in the right order, it looks like. It was negative 1/2 for circulation. And then this one's done with the right order as a sum. And this one spits out a number.
So that's what you would think about, where you take the I component in terms of x and the j component in terms of y.
Oh, here's my problem. You see, I wrote this formula wrong because you can see I just put an I here for no reason. This shouldn't be there. It should be like this. All right, that's good to know. All right, so that's how it's done there. And then obviously the next one is just done proper. So you just take the partial of x here plus partial of y here, evaluated at still the same bounds, right?
Yes.
Yeah, same, because it's over the same,
So
this is a
2y
surface.
plus 1 plus what, x minus 1, which gives you 2y plus x, which given from 0 to 1 of dx dy, we're given 2y plus 1/2 minus 0, 0 to 1 of 2y plus 1/2 is that's weird.
I think the partial spits out 2y plus 1 on I plus x minus 1 on j.
Yep.
And then obviously evaluating at 1 to 0, it's gonna,
Yep.
what is this,
And
3
you
halves?
you just drop the i's and the j's.
Yeah, because I wrote it mistakenly because of my own formula. That is that. Let's just look down here. There's nothing else. Oh, look at these things. These are probably great. Mass and moments.
But I got 3/2 for the answer, and 3/2 is the question answer in the back of the book.
That's all we need to know. All right. So to recap, catch those dubs.
Yep.
I suppose that's what's
Living
gonna
on
have to
prayer.
happen. Living on the prayer. Yeah. All right. Well, that's fun. I have to go eat dinner. I haven't had dinner.
Yeah.
It's dinner time. For me, it's 7 p.m., 7:30 p.m. All right.
I see that.
Yeah, because I have gamer time, unlike you plebeians.
For me, it's 6:30, and I have a coding assignment due at midnight.
Oof. I have
Coding final, should say that.
I have a bunch of stuff due. I don't actually have anything due. I just have 2 finals tomorrow. This one. What time is this final?
8.
8 a.m.
It's a what? What's the timing?
9:30.
I think it's 2 hours 15
Uh,
minutes.
yeah, 2 hours 15
Wow.
minutes, but we're given 2.5 hours, so till 10:30.
So 9 to 11:30.
Your time, yes.
Yes, cool. All right. So 8 to 10:30. All right, that's good. So I'm gonna cut this off or stop the share and cut off the recording.